Chapter 2, homework number 1. 2-6. A pattern has 5 tiles in figure 0 and adds 7 tiles in each new figure. Write a linear equation that repeats this pattern. Okay, so we have figure 0, and then figure 1, figure 2, ... The tile pattern has 5 tiles in figure 0, and then it adds 7 tiles in each new figure. Alright, so that means figure 1 will have 12 tiles. And figure 2 will have 19 tiles. So our growth rate is 7. And our starting value is 5 tiles in figure 0. We started with 5 and we're adding 7. Alright, and then we have this equation, y equals mx plus b. So the growth is the number you put right before x, and then the starting value is the number you put in for b. And so the equation is going to be y equals 7x plus 5. (2-7). Benjamin is taking Math 1 and is stuck on the problem shown below. Examine his work so far and help him by showing and explaining the remaining steps. So he starts with the original problem. Simplify 3, a to the power negative 2, b to the power 3. So what Benjamin noticed is this is the base, this is the exponent. So he's going to repeat the base 3 times. These are all multiplication symbols. So what we can do is put the 3's next to each other. Let's rearrange. 3 times 3 times 3. And then we have a to the power negative 2 times a to the power negative 2 times a to the power negative 2. And then we also have 3 b's times b times b times b. Alright, so 3 times 3 is 9. And then if we times that by 3 again, that is 27, a to the power. When you multiply two terms with the same base, their exponents add. It's negative 2 plus negative 2 plus negative 2. And then b times b times b, that's b repeated 3 times, so that's b to the power 3. So you're going to get 27. If you add all these together, that's a negative 2. That's a to the power negative 6 equals, we just have b to the power 3. Alright, so there's one more step. I'll let you finish this one. You have to deal with that negative exponent. Alright, examine the function at the right. Estimate the values below. The values don't need to be exact, but should be close. H of 1. So this guy in the parentheses is the input, x. So you go to the x-axis and you find 1, which is right there. And then if you go up to where you hit the line, what is the y value? I'm going to say that's about 2. Alright, and then part C, x when h of x equals 0, there's going to be 5 answers. So find where this is y. This whole thing means y, right? So find the y-axis where it's 0. And then you go left and right. What are the x values? Well, 1, 2, 3, 4, 5. There's actually going to be 5 x values. This one looks like 4, 2, 0, negative 2, and negative 6. So what does that mean? That means if I go to 4 on the x-axis, the output or y is 0. If I go to 2 on the x-axis, the output or y is 0. So y is 0 at all of these locations, right? And that's what it's asking you to do. Where is y 0? And then find the x. 2-9. Let's do C. Careful, this -5 is outside the square root. So what we're going to do is we're going to simplify this first, take the square root, and then subtract 5 from whatever that is. So we've got 3 squared, which is 3 times 3, plus 4 squared, which is 4 times 4. 3 times 3 is 9, plus 16, and then take away 5. All right, so 9 plus 16, we got to take the square root of 25, and then take away 5. So the square root of 25, we have to do this first, right? You can't just do square root of 20. That's not how it works. Square root of 25 is 5, and then take away 5. So my answer is 0. All right, and I'll start the next one for you, part B. We have 5 to the power 1 plus 2. You got to do the parentheses part first, right? So that's 5 to the power 3 plus 8 minus 6. All right, and 5 to the power 3, that's 5 times 5 times 5, and that is 125 plus 8 minus 6. I'll let you finish that one. 2-19. Which equation below has no solution? Explain how you know. Well, let's look at A. And in case you forgot, to solve this one, you must distribute the 4. The 4 times x is 4x plus sign. 4 times 1 is 4. All right, and let's draw the railroad tracks. Okay, so we have the smaller x. I'm going to take away 2x. That cancels. That's a 0 pair. 4x minus 2x is 2x plus 4 equals 4. Subtract 4 from both sides, and you've got 2x equals 0. So 2 times what number is 0? Well, that's got to be 0, right? 2 times 0 is 0. That works. So what do we say? We say that x equals 0. If you write no solution here, you are wrong. There is a solution, and it is 0. And if you want to follow the steps, the last step is divide by 2. 0 divided by 2 is 0. Okay, so that should help you with A, and then you can do B, and make sure you explain. 2-20. Evaluate the expressions below for the given values. So we have, let's do B, and then let's go over to C. Okay, so 5 minus x is -1. -1 subtract 2, square that, and then 5 minus that. So we go inside the parentheses first, and we do 5 minus something squared. Well, -1 minus 2 is -3. All right, so -3, because it's in parentheses, is our base, and that's our exponent. This is 5 minus -3 times -3, and -3 times -3 is +9. And this minus sign is a subtraction, so we're doing 5 subtract 9, which is -4. Okay, this is a fraction. -5 over whatever k is plus 1, and k is -1. So this is going to be -5 over -1 plus 1 is 0. And anything divided by 0 is no solution. Or you might even write undefined. Can't divide by 0. 2-18. Calculate the slope of the line shown on the graph at the right. To calculate the slope, draw a slope triangle. And our slope triangles usually look like this. It's got to be a right triangle or like that. So here's our 2 dots. We connect them to form a perfect right triangle. All right. And then we do rise over run. So this one, that's actually 4. So from 0 to 4, that one is 4 units long. And then let's see what we have over here. This is going to be 6. And I believe 1, 2, 3, 4, 5, that's -6. So if I go from -6 all the way to positive 6, then that is a total length of 12. So we have a rise of 4 and a run of 12. So slope is equal to rise over run. All right, and as demonstrated, that's my rise, that's my run. So I'll let you finish this one off. Make sure you simplify. This one can be simplified. Simplify the fraction. Calculate the output for the function with the given input. If there's no possible output for the given input, explain why not. So well, let's plug in 1. F of 1 equals, and replace x with the input. It's the replacement value. So that is x becomes 1. It's 1 fraction 1 minus 1, and that is 1 over 0. And this is undefined or no solution, but I'll let you explain why not. If you need a hint, I talked about it on 2-20. 2-22, evaluate. All right. So I like to turn all these into improper fractions. You can do whatever you like. I'll work on A and then D. So to turn this into an improper fraction, in case you forgot, you multiply those, which is 40, and then you add this number on top, which is 42, all over the original denominator 5. So multiply these. 3 times 4 is 12. Add 1, that makes 13, all over the original denominator of 4. Okay, and then when you divide by a fraction, you keep the first, you change the sign, and you flip the second. And then let's multiply straight across. 4 times 42, that's going to be 168, and 5 times 13 is 65. Okay, part D, we've got negative 7 plus 2/3. That's the same as negative 7 over 1 plus 2/3, right? I can put any fraction, or I'm sorry, I can put any number over 1, and it doesn't change anything. Okay, so we somehow need this bottom to become 3. All right, so maybe I'm overthinking this here, but let's multiply the top and bottom by 3. Negative 7 just of this fraction. So negative 7 times 3 is negative 21 over 1 times 3 is 3. Okay, so then we become that, and now that they have a common denominator, that was the problem before, there was no common denominator. So we've got a common denominator of 3, so we just add straight across the top. So what is it over 3? It is negative 19 over 3. Now I say I'm overthinking it because I could have just written negative 7 and 2/3. You know, negative 7, add on 2/3. Oh, I'm sorry, that's actually wrong. Whoops. Because this is negative, and that's positive, if I add on 1/3, that's going to be negative 7 plus 1/3 is going to be negative 6 and 2/3. And then if I add on 2/3, it's going to be negative 7 and 1/3. But maybe that was a little more complicated than I was originally thinking, so you might want to do it this way, the good old common denominator method. Okay, 2-33. Your new expression should not contain negative exponents. Rewrite all of them. Let's start with A. Okay, so we have 5x cubed times negative 3x to the power negative 2. Now because it's times, I like to rearrange stuff. Let's put the big numbers next to each other. 5 times negative 3, and then we have times x to the power 3 times x to the power negative 2. Now 5 times negative 3 is negative 15 times x to the power. When you have two terms with a common base, the exponents have to add. So the exponent, the new exponent, is 3 plus negative 2. All right, so this is just negative 15 x to the power 1. And since it's to the power 1, erase it. It's just negative 15x. Part B. This is 4p to the power 2q all to the power 3. That's my base, because it's in parentheses, that's my exponent. So that's 4p squared q, 4p squared q. Repeat the base 3 times. Alright, and let's rearrange. We've got 4 times 4 times 4, p squared times p squared times p squared, and then q times q times q. Now I will let you finish this one off. If you need a hint, you can go up and watch this problem. It was 2-7. I solved most of that one. So this one's very similar to 2-7. Okay, 234. Which graphs below have a domain of all real numbers, and which have a range of all real numbers, and which are functions? So let's check A. The domain, this is an arrow and that's an arrow. So what that tells me is the graph keeps going up to the right forever, specifically to the right. And then this one goes down and to the left forever, specifically to the left. So you can see that the whole x-axis is going to get kind of covered by this function as it travels. I'll always be able to find an x here, and from that x I can go up and hit the graph. So the domain is all real numbers. Alright, and let's check the range. And so the range might be a little bit more apparent on this one. This one goes up forever on the y-axis, and it goes down forever on the y-axis. So this one is also all real numbers. And this is also a function. The tool to help you is the vertical line test. Alright, so you can draw a vertical line anywhere, and it only will strike the curve once. So that's a little tool to help you out. Alright, now let's look at C. Domain, range, function or not. Well, this one, right away you can tell it doesn't pass the vertical line test. So it's not a function because there are inputs, like this one, this input has 2 different outputs. So it's not a function because this input has 2 different outputs. Let's check the domain and range. Well, that's as far left as it goes on the graphs, and then it goes forever to the right because of arrow, arrow. So the domain is not the whole x-axis. So that we'll cross that off. It's not going to be all real numbers. But how about the range? Let's see. This is going to go to the right and up forever. This is going to go down and to the right forever. Specifically down and up. So the whole y-axis is going to be covered, so to speak, by this graph. If I keep going up and up and up, I'll always be able to come back over and hit the y-axis. So there's always going to be a graph, an x value corresponding to it. So we write all real numbers. Right, and I'll let you do B. Okay, here's my 2 functions. Let's look at A. F of -2. I'll let you do that one. Let's do B. G of -2. So that's going to be, it's negative x squared, right? And if I want to plug in -2, that's going to be negative 2 squared. So it's going to be negative, and then we have -2 times -2. That gets repeated twice. So it's going to be negative, and this becomes positive 4, right? It's going to be -4. So this, because of this negative sign, the answer will stay negative. It's a triple negative. C, find x if f of x equals 0. So if f of x becomes 0, if this whole thing, parentheses and all, becomes 0, then we have 0 equals 3x minus 9. And what's the input? What would x have to be to output 0? Well, add 9. 9 equals 3x, and then divide by 3. So x equals 3, right? 9 divided by 3 is 3. 2-30. When Yoshi graphed the lines y equals 2x plus 3 and y equals 2x minus 2, she got the graph shown at the right. One of the lines at the right matches the equation, and the other matches this equation. Which line matches which? Draw arrows if that helps. Well, this one has a positive starting value of 3, which is right there, so it must match that line, which is line B. and I'm drawing arrows because that's what it says to do. This one has a starting value of -2. There's -2 on the y-axis. So that must be line A. Okay, Yoshi wants to add this y equals 2x plus 1 to her graph, predict where it would lie, and sketch in the graph above to show its position. Okay, so y equals 2x minus 2, y equals 2x plus 3. It seems like these lines are going to be parallel to each other, right? They just have a different starting location. So they have the same slope, they grow at the same rate, but a different starting value. So this one should have a starting value of right here at 1. So the starting value is at 1. And then it grows by 2 tiles, or 2, each figure. The growth is 2. So if I go over 1 to the right, that just means I should go up 2. And then if I go over 1 again from here, I go up 2. So starting is at 1, the growth is at 2. So y equals 2x plus 1 is in between lines A and B. But it's parallel. You can see it's parallel. They're never going to touch. All right, make sure you finish part C. 251. What number is part of the domain? All right, and I'll let you solve this one, but just think about what number turns x plus 5 into 0? So what number x? What number can I plug in for x that would turn the bottom, x plus 5, into 0? I'm not allowed to divide by 0. So if this becomes 0, that's not allowed. All right, which of the expressions below are equivalent to 16x to the power 8? Find all correct answers. All right, so I'll do this one because it's a little trickier. All right, so we have 1 over 16x raised to the power -8. So x to the power -8, we're going to rewrite that. And I'm going to leave the -1 alone for a second. So it's 1 over 16. And then, if you remember, this just becomes 1 over x to the power +8. Cross line, change little sign. So this is 1 over 16 x to the power 8. And then we have this -1 thing going on outside the parentheses. So something to think about is this is the base, and the exponent is -1. And so this is just power to a power. And when you have the power to a power, the exponents inside multiply. So 1 raised to the power -1, then that's going to be, multiply these, -1. 16 to the power 1, multiply, and that's -1. x8, x to the power 8, and then power to a power, so we multiply the exponents. So it basically just makes all of the exponents inside negative. And then what that does is when you have a negative exponent, everything just flips. So this flips, that flips, that flips. Everything crosses the line. So the 1 goes down to the bottom, and the 16 and x to the power 8 go to the top. And after you cross the line, you change the little sign back to positive, so it's just 16x to the power 8. So that was the tricky one. And I'll do one more, and you can try the rest. So this is going to be 16x to the power 4 squared. That's the base. The base is 16x to the power 4. And then the exponent is 2. All right, so that's 16 times 16. And then we have x to the power, x to the power 4 times x to the power 4. And so right away you can see 16 times 16 That's not going to be equivalent to 16, so not that one. For the line graphed at the right, what is the slope? What is the y-intercept? What is the equation? All right, so to find the slope, what you need to do is draw a slope triangle. Pick a point like here. It has to be a lattice point, a grid point. So you can't pick a point like there because it's just in the middle of everything. You have to pick a point right at the corner. All right, so there's my slope triangle. This one is 1 unit tall by 2 units wide. The rise is 1 and the run is 2. And since this line is going downhill, we'll make this a -1 rise. We're rising downward, we're going down. The slope is rise over run. That's going to be -1/2, or -1/2. The y-intercept, here's the y-axis. Where does the line cross the y-axis? It crosses at 1. You can write 0, 1, or just 1. All right, and then we're going to write our equation, y equals mx plus b. This number is the slope, and then b, that's where the y-intercept goes. So plug in your two numbers. I'll let you write the answer, y equals something. All right, we've got a couple more to go, 2 more. 116. Rewrite each expression into an equivalent simpler form with no negative exponents or parentheses remaining. Let's start with a. A, we have a fraction. So I like to separate and group things together. We'll group the numbers together. Times. We'll group a to the power 3 on top of a to the power 4, and then the b's. B to the power 2 all on top of b. Okay, so 14, 21. 7 goes into 14, and 7 goes into 21. So let's divide the top and bottom by 7. Goes into 14 twice, goes into 21 3 times. So that's 2/3. All right, now we've got 3 a's on top, 4 a's on the bottom. So if you write it as a times a times a on the top, there's 3 a's on the top and 4 a's on the bottom. So what I'm getting at here is a's are going to cancel. A's are going to cancel. There's going to be 1 left, and it's going to be on the bottom. And then over here, we've got b squared. That's just b times b all over b. So b's also cancel. There's 1 b left, but that b is on the top. All right, next, let's go over to c. You've got 4x to the power 18. I like these because this crazy looking base has an exponent of 0. And anything to the power 0 is 1. And when you divide something by 1, nothing happens. Okay, part E, this is our base, and that is the exponent. So we're going to repeat this base 4 times. And exponents repeat multiplication. So these are all multiplying each other. If I group the numbers, it's 3 times 3 times 3 times 3. And then if I group the terms with a w base, that's times w to the -2 times w to the power -2 times w to the power -2 4 times. Use a calculator. It's 81 times. And then when you multiply terms with the same base, the exponents add. So these all have the same base. If we add all the exponents, that's w to the power -8. And this has a negative exponent, so we cross the line and change the little sign. All right, and that's going to be 81 over w to the power 8. Last one, evaluate. Okay, let's look at b. b is 6 minus 5x minus 9 squared, and we plug in 1. So it's going to be 5 times 1 minus 9, square that, and then 6 minus that. Now we have to go inside the parentheses first. So it's 6 minus something squared. Well, 5 times 1 is 5. And then 5 minus 9 is negative 4. So it's 6 minus negative 4 squared. Now because of PEMDAS, we went inside the parentheses first. Next we're going to do the exponent. 6 minus negative 4 squared is negative 4 times negative 4. Alright, so it's 6 minus 16. And 6 minus 16 is negative 10. D. We have 2 times m, which is negative 2, and it's all over n minus 1. That's 3 minus 1. Subtract negative 2 cubed. Make sure you use parentheses, and then subtract 3. So let's start simplifying here. We've got exponent, negative 2 to the power 3 is actually negative 8. Use a calculator. If you can't see why, it's negative 2 times itself 3 times. Alright, so this first one, negative 2 times negative 2, is going to be positive 4. And then positive 4 times negative 2, positive times a negative, is going to be negative 8. So it's like a triple negative. The sign stays negative. Alright, so then we have 2 times negative 2. That's negative 4 over 3 minus 1 is 2. And then here we're subtracting negative 8. When you subtract a negative number, it's like adding it. Alright, negative 4 divided by 2, that's going to be negative 2 plus 8 minus 3. Negative 2 plus 8 is 6 minus 3, answer 3.